I had some problems with my test run in the Brumby. I was getting low cell voltage alarms, and there was even a high pack voltage alarm. So there's something weird going on. Also, there were loss of communications alarms, which were overwriting the other ones. So at one stage I was thinking, well, why is that alarm clearing? It's because the loss of communication ones will clear a low cell voltage, for instance. Now I've been looking at it and I think I've figured out what's going on. When I had the laptop hooked up to the BMS, it gives me, every 3 seconds, it gives me a readout of every BMS module's voltage as reported by the BMS master. The BMS master collects them all up, sends it through to the laptop, as well as doing its own internal error checking and all of that kind of stuff. So I could see that some of the data being sent through to the computer was nonsensical. It had values in there that the modules can't transmit, and there was some weird stuff going on. So this reminded me that when I did my BMS, my battery module upgrade, I upgraded the firmware on each of those module circuit boards. And one of the things that was upgraded was the communications between them. So I've made it so that the communications can now be a lot faster, but one of the ways that I did that was I took out the error checking in each module. So the packet of data gets sent from module to module. It used to be that each module would check that packet of data, and if it was not correct, it would discard it and just wouldn't send it on to the next one at all. Now I've changed it so that it does send it on, it still checks it, but then flags it as bad data if it's bad. It still goes all the way around. So previously those packets of data didn't get to the master, and now they do, and the master has to do something with them, with those bad packets. And so what I've found is a bug in the master dealing with those bad packets of data, and so it wasn't necessarily ignoring them properly. And so you got bad data through, and it was saying that it was low cell voltage and high cell voltage and all those sorts of things because it was corrupt. So I've fixed that, and what it'll do now is if it gets a bad packet of data, the master just ignores it. So I've gone for another run, and now with this run here, the fourth run I've got here, I've got in the section where I was accelerating in the Brumby, accelerating reasonably hard. The slow accelerations didn't seem to cause it, but the hard accelerations did. I've got no data there returned at all. So that says to me that the master unit was receiving bad packets of data and therefore not sending them onto the computer. Adds up to be about 18 seconds worth of data as I'm accelerating, so it's a reasonable amount. I was accelerating for probably about that amount of time, that sounds right. It was up a hill, I wasn't accelerating really hard, but yeah, maybe drawing about 200 amps, something like that. Now, what could cause that? It's presumably going to be interference between each cell. So you've got a big loop, the master sends out the data, sends out a request for data, it goes around every module, goes into a big loop, comes back to the master again. It could be anywhere around that loop, getting interference from something, but if it's under acceleration, it makes sense that it's going to be the motor controller. And so there are battery modules directly underneath the motor controller. Seems like that would be the most likely place to get interference if it's only happening under acceleration. So let's go and have a look under the bonnet of the Brumby, and I'll show you what I'm talking about. So here's the BMS master. The data goes in a big loop, goes through the cells in this box, all to the back of the car, through all the cells in the back box, and up and through the cells in this box here. Now this is the one that's underneath the motor controller. That's the motor controller there. It's got a metal plate underneath it, and that metal plate is earth to chassis ground, so there'll be some level of protection there, but not necessarily a huge amount. The other thing that could be causing the interference is the motor here. So here is the connection for the BMS wires. They go through this here, in through this connector into this box and back out again. It goes in and out through this same one. So it's right in front of the motor, and it's right on, and the There's also communications up and down inside this box, which is right underneath the controller. It's reasonably difficult to get into that box to provide any further shielding, but it's pretty easy to do this one. But first of all, the first test is to see, is this actually the problem? And I figured out a way of doing that, which is to use this thing here. What's it called? It's a Brumby BMS box bypass. So this is designed to fit into here. And so you've got wires in and out. And so what it'll do is the communications will come along here and straight back again. And so we'll just bypass this box altogether. So I plug this into there. Now the communications are going up and back again and not going through that box underneath the controller. What I'll do is I'll tie this back underneath here so it's out of the way of the motor. And so interference, if it's coming from there or there, hopefully is going to be lessened, hopefully all the way gone. I'll tie it in under there. I'll show you what the BMS is doing. So the BMS is perfectly happy with those 4 cells gone. So there's 4 cells now that are not in the loop. It's still reporting the high and low cell voltages. The total voltage is now 154 instead of, it was up around 170, something like that, 160 something. So it's just happily working away. It doesn't have as many cells, but it doesn't really care. So I'll go for a drive and see if I get any communications faults. Well, that was good. So what I found then was there were no errors, no faults recorded by the BMS master there. On the computer log, I found that there were no gaps this time. So no gaps in data. We received data all the way through our acceleration. Acceleration very similar to the last few times when we've got either errors or no data. Which means that, yes, I think my theory is confirmed. There is interference somewhere in under the bonnet to do with the motor controller, or motor or controller. So the next step to do is to put this, instead of, I had it tied back under there away from the motor, I'll tie it over here so that it's still running across the front of the motor. If that picks up interference, then it's presumably from the motor. If it doesn't, then presumably the interference is inside the box there. I reckon it probably is inside the box, but it would be much easier to shield this cable than it is to undo that box and try and shield individual wires inside there. So there's lots of wires in there and none of them are shielded. There's a couple of obvious ones along the top. Those would be the ones to shield first, but it's probably an hour job to get this off and back on again afterwards. There's lots of connections to undo and do back up again. So I've just been for a run with that bypass and the connector strung up here next to the motor. It was exactly the same as last time. No errors, no gaps in the data. This means that the problem is coming from inside that ridiculously hard to get into box. Communications come along through here. There's 4 cells inside this box here, 2 on each end, and they talk. So the communications line comes in here, goes to these 2 cells here, then along, then those 2 cells there, then along back. And so those long lines are the ones that are likely to be receiving the interference. I had to think as to what's the difference? Why is there interference now when there didn't used to be before I refurbished the battery modules? And I remembered that I replaced the metal aluminium sides with perspex sides. And so I reckon that's probably the difference. The metal sides were inside this wooden box, but down this side and down this side here, so each side of the cells. I'm guessing this is more likely to have received interference through this side because it's got the motor here. So the way this controller works is it has DC coming in here, and then it converts it into a lower voltage DC basically, and higher current. And those cables go straight down there. So they're running down the end of the box. We could have interference coming through from those cables. We could have interference coming from the controller itself. The controller itself is sitting on top of a thick aluminium plate, which is bolted to a thin aluminium plate, and the whole thing is earthed. So there should be reasonably good shielding from the top, but one of the cables does run directly along underneath there on top of the cells. So that one is quite possibly subject to interference. The other one runs right down here somewhere. I'm not sure if it's on this side or the other side, but if it's on this side, then that is quite close to the motor. So the logical thing to do is to pull all this apart and shield those wires inside, but it's pretty difficult to get apart. So the first thing I'm going to do, just to see if it works, is to put a sheet of metal across here, and maybe even one on the end there if I can make that work. I've come up with a couple of things to work with. The first is this metal aluminium plate. So this is from the sides of the battery modules. This is what I took out and replaced with Perspex. That should be a reasonable size to put down there. It doesn't cover the entire length of the battery box, but it comes close. I can put up this end, and then I can avoid the connections at that end there. Now I'm only doing this temporarily to see if it works. And what I've got to put it in place is this metallized tape. So this is used for insulation, so that foil-backed insulation. I've measured this. There's 0 ohms resistance across it, so I assume it's aluminium. That should be quite conductive. It doesn't conduct once it's stuck on, so if I stick this onto the aluminium plate, that won't conduct through to the aluminium plate because it's got the sticky back on there, so I need to sort of fold it over to make that work. Just putting the plate on there without earthing it might do something, but it's going to be better if I can earth it. If you earth it, then it'll take so it'll receive radio waves basically, and they will be turned into electricity and be conducted away if it's earthed. If it's not earthed, then it might just sort of retransmit again. It would probably be better than nothing, but yeah, we'll see how we go. So I've installed my metal plate. So the metal plate goes from that end there. It's got a little fold over the end of it, so it goes around the corner just a tiny bit, up to here. Up to here. And then I've put tape on to keep it on there. The tape is working very well. It's sticking very well to that wood and the metal. Now I've folded, if you can see that there, I've folded underneath there. That's the way that I've made my electrical connection. And I've also put 2 runs of tape across behind here. It's a bit hard to see, it comes out the bottom there. It's gone behind these cables here. So I've got a couple of runs of tape behind the big thick cables that go to the motor. For electrical conductance, let's just see. So that's on conductivity. We'll go through to chassis earth and test around. So there's that's some tape. That's the aluminium plate itself. That's another bit of tape. They all seem to be connected quite well. So I might go for a drive and see if it's made any difference whatsoever. So we've been for our run with the foil on the outside of that box, and now we'll have a look at the computer and see how we go, if the BMS is communicating any better than it was. So the first spreadsheet here I've got, so this is the data that's output from the BMS to the laptop, and it's in each row here is a list of voltages reported from the BMS, the voltages of each cell. So there are 43 cells. There's a column here for the time. A column, the B column there is 1 or 3. So 1 means volts, 3 means temperature. So it's reporting 29 volts and then 1 temperature, so temperature every 30 times. And then it reports 43 numbers. Those numbers are hex code that need to be decoded into the voltage, but you can see most of them are 22. There's occasional 23, just a couple. So they're well balanced. The 23 is a lower voltage than 22. It goes in reverse like that. And so the BMS reports the voltage every something like 1.5 seconds back to the computer. And so each one of these is about 1.5 seconds worth of data. So what we can see here is we're going along recording nicely. We record a temperatures one there. Temperatures are a bit different. They look quite different. And then we go down here and we have some data not recorded. This is typical for if I accelerate. And so you can see the data missing there. Oh, I may not have mentioned, this is the baseline data, the run I went before I put the foil on. So yeah, you go down here and there's a couple more. I think I did 2 runs on this one, but whenever there's a big block missing there, that means I'm accelerating. So let's compare this to the one I just did with the foil on it. So I've got them side by side, and you can see very similar. The voltages are slightly higher. The raw number is slightly higher here, which means the voltages are slightly lower, which makes sense. I've gone for a little run and used a little bit of power. But the gap here is still happening in a very similar manner. So that gap there was that wide. Yep, it's just as bad. Doesn't seem like it's done anything at all.